Okay, we're going to use the properties we just learned about to solve some real-world type situations. So this first question asks you to find the perimeter and area of the rectangle, and this rectangle has a length of 4a cubed b and a width of 3a squared. So why don't you attempt to find the perimeter and area on your own? Pause the video now. All right, let's see how you did. So I'm going to start out with the perimeter. I know that perimeter of a rectangle is just 2 times the length plus 2 times the width. Now, since I'm given length and width, all I have to do is substitute those values into this formula, and I've got my answer once I simplify. So 2 times the length, which is 4a cubed b, and we're going to add that to 2 times the width, which is just 3a squared. Excellent. So all I have to do is simplify these two terms. 2 times 4a cubed b are only like terms there are the numeric terms 2 and 4. So that's going to simplify to 8a cubed b. And over here, that's 2 times 3a squared. And that's going to equal 6a squared. Now, you might be tempted to combine this a cubed and this a squared, but remember what the product of powers property states. If you are multiplying like or terms with like bases, then you can add the exponents. But we're not multiplying a cubed and a squared. All right, they're part of two separate terms, and they're not like terms because this is saying we have the quantity 8 cubed b 8 times. 8 times. All right, and here we have the quantity a squared, and we have that 6 times. Well, a squared is not the same as a cubed b, so they're not like terms. Let's try and find the area now. Now we know area is equal to the length times the width. All right, so let's see. Our length is 4a cubed b. I'm going to go ahead and put that in parentheses. 4a cubed b. And we're going to multiply that by the width, 3a squared. And now we have one big multiplication problem. So rearranging the terms in my head, because I know multiplication is commutative, we've got 4 times 3, that's going to be 12. We've got a cubed times a squared, it's just a to the 3 plus 2, so that's a to the 5th. And then we just have a b times, it's just there. So we're just multiplying it by 1. And so that's 12a to the 5th b. And there's our area, and there's our perimeter. So these are your answers. If you didn't get it the first time, why don't you go back to the beginning of the video and try to see if you can get these answers on your own. All right, let's try another problem. The area of the rectangle below is 18x to the 7th y to the 5th. If its length is 6x to the 4th y to the 4th, what is its width? So we're given length and we're given area, and we want to find the width. So why don't you try this one on your own? All right, and I'll give you a hint. Let's start out with the formula for area of a rectangle. Area equals length times width. And ask yourself, of these 3 variables, if you can find 2 of them, then you can solve for the unknown third variable. So pause the video now and attempt this problem on your own. All right, so let me show you how I approached it. I know that I'm given the area. In the problem, it says that the area of the rectangle is 18x to the 7th y to the 5th. So I'm given the area, and I'm given a value for length, which is 6x to the 4th, y to the 4th. So I'm going to fill those values in. I know that my area is 18x to the 7th, y to the 5th. And that's going to equal, and I'm given a value for length. Length is 6, and I'm going to put this in parentheses. Length is 6x to the 4th, y to the 4th, and I'm going to multiply that by my as yet unknown width. So now I need to isolate w, my variable for width. So what am I going to do? I'm going to divide both sides to undo the multiplication, I'm going to divide both sides by 6x to the fourth y to the fourth. And I'm going to divide this side, 6x to the fourth y to the fourth. And I know that these terms are going to cancel. 6 over 6 is 1, x to the fourth over x to the fourth is 1, and y to the fourth over y to the fourth is 1, leaving me with my isolated variable w and an expression on the other side. So I'm going to rewrite this over here as width equals, and here's my expression, 18x to the 7th, y to the 5th, all over 6x to the 4th, y to the 4th. So now I can begin using the quotient of powers property to simplify this expression. I know that 18 over 6 is just 3. I know that x to the 7th over x to the 4th is x to the 7 minus 4, so that's going to be x to the 3rd, or x cubed. And then y to the 5th over y to the 4th is y to the 5 minus 4, so that just leaves us with y to the 1, or just y. And so our width is 3x cubed y. The pattern below is made of uniform square tiles with a side length of 3x squared y to the 5th. What is the total perimeter and area of the tiled pattern? So first let's look at this word uniform. In this context, uniform means the same. So all of these tiles are square, and they are the exact same kinds of squares. So they've got the same shape, the same size. And we know that the side length of one of these squares, or I should say of all of these squares, is 3x squared y to the 5th. Now, using that information, we need to find the total perimeter and the total area of the tiled pattern. So let's attack perimeter first. So the perimeter of any figure is just the total distance around the figure. So as we can see, we're probably going to have to take the sum of all of these little sides, or the sides of the squares that are on the edge or perimeter of the figure. So since all of the sides are uniform, they're all 3x squared y to the 5th, we just have to count up how many sides are on the outside of the perimeter. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So if the length of one of the sides is 3x squared y to the 5th, then the total perimeter is just 12 times the length of one of the sides, 3x squared y to the 5th. And so this should be pretty simple. All we have to do is multiply 12 by 3, which is going to be 36 x squared y to the 5th. And that gives us the perimeter of the entire figure. Now, let's take area. Now, area is going to be a little different. Again, we're not dealing with a rectangle or a simple shape. We're dealing with what's called a composite shape, a shape made up of other shapes. In this case, this shape is made up of all of the same kind of shape, this uniform square tile. So if we were to find the area of one square, and I'll denote this by A sub S, meaning the area of one of the squares. If I were to find the area of one of the squares, then in order to find the total area, I just need to multiply that area by however many squares I have. And I've got one square, 2, 3, 4, 5, 6 squares. So let's find the area of one square. Well, the area of a square is just the length of its side squared, or multiplied by itself. So we just take the length of one side, 3x squared y to the 5th, times itself, 3x squared y to the 5th. And so the area of one of these squares is going to be 3 times 3 is 9, x to the 2 times x to the 2 is x to the 2 plus 2, or x to the 4th, and then y to the 5th times y to the 5th is y to the 5 plus 5, which is 10. Now be careful, although we found an area, this is the area of only one of the squares. We want to find the entire area. So we're going to take the area of one of the squares and we're going to multiply it by 6. So 6 times the area of one of the squares. 9x to the 4th, y to the 10th, and multiplying this value by 6 gets us 54 x to the 4th, y to the 10th. And so we've successfully found the perimeter and area of the figure.